In this video, I'm going to show you the IUPAC nomenclature for hydrocarbons. The content of this part of the nomenclature video series is going to be what are alkanes, then what are the alkyl groups, alkyl halides, and common names of alkanes. Following to that, we are going to speak about the IUPAC rules for alkanes nomenclatures. I'm going also to upload part 2, which is going to be a nomenclature of alkenes with a sample definition of alkenes, IUPAC rules of alkenes nomenclature, cis-trans or EZ isomerization, and a third part is going also to be uploaded, which is nomenclature of alkynes, including what are alkynes, the IUPAC rules for alkynes nomenclatures, and so on. So let's start with alkanes. What are alkanes? Alkanes are saturated hydrocarbons. When we say saturated hydrocarbons, this means that they are hydrocarbons in which all the bonds are single bonds. They are hydrocarbons in which all the bonds are single bonds. Okay? Alkanes, also known as paraffins. So this is another name for the alkanes, which is paraffins. So alkanes are saturated hydrocarbons that can also be named as paraffins. The carbon atoms in alkanes are linked together by single bonds. Here in this table we have the alkane with one carbon is called methane, alkane with two carbons called ethane, and of course you can notice here that all the names of the alkanes ends as ane with A-N-E. Methane, ethane, propane, and butane are just common names for the first four members of alkanes. After that, after just butane, the names of alkanes are derived from Latin prefixes of numbers, starting from pentane means alkane with 5 carbons, hexane means alkane with 6 carbons, heptane alkane with 7 carbons, octane alkane with 8 carbons, nonane 9 carbons, decane 10 carbons, and so on. You can see that the general formula for alkanes is CnH2n plus 2. This means that usually the number of hydrogen is following that rule regarding to the number of hydrogen. So for example, if we have C5, so the number of hydrogen is going to be 2 by 5 plus 2 means 12. So C5H12 is pentane. So all alkanes are following this general formula. Whenever I have a hydrocarbon, if it's following this rule regarding the number of hydrogens and carbons, so this hydrocarbon is alkane. Now let's go to other type of alkanes, which we call cycloalkanes. Cycloalkanes are also called alicyclic hydrocarbons. Alicyclic hydrocarbons means aliphatic cyclic hydrocarbons. So cycloalkanes contains only carbon and hydrogens, and they are connected together with single bonds, still carbon-carbon single bonds, but this time the carbons are joined up in a ring, as you can see: cyclopropane, cyclobutane, cyclopentane, cyclohexane. is CnH2n. The general formula of cycloalkane is CnH2n. It's different than the general formula of the alkane in a chain. The general formula of alkane contains 2 more hydrogen atoms. The general formula of alkanes have 2 more hydrogen atoms than the cycloalkanes. In the cycloalkanes, because of the ring is closed, so 2 hydrogens are omitted from the corresponding alkane. And of course, as you can see, the lowest member of the cycloalkanes, or the smallest member of the cycloalkanes, is the cyclopropane, because we can also form a ring with at least starting from 3 carbons. There is no ring that can be formed by 2 carbons. So the first member in the cycloalkanes is the cyclopropane. So now we have some idea about alkanes and cycloalkanes. Let's go to a third groups of compounds or branches that are derived from alkanes. Let's see what does it mean by alkyl groups. Alkyl groups in general are alkanes minus 1 hydrogen. Alkanes minus 1 hydrogens. Those are the alkyl groups. This hydrogen is omitted because alkyl groups are considered branches that are connected to a bigger or larger compounds. Okay? They are usually abbreviated as R. They are usually abbreviated as R. For example, from methane, the alkyl group is methyl or methyl group. From ethane, the corresponding alkyl group, which is formed by omitting 1 hydrogen, is ethyl group. For propane, the corresponding alkyl group that is formed by emitting 1 hydrogen is the propyl group, and so on. So now we have some idea about alkanes, cycloalkanes, and the alkyl groups which have the simple R, the general simple R, and they are derived from the corresponding alkane minus 1 hydrogen atom. Let's now go to another compounds that are also derived from alkanes, or groups or compounds that are formed by alkyl groups and halides, which are called alkyl halides. Alkyl halides are alkanes that in which 1 hydrogen is replaced by a halogen. Of course, we know that halogens are Cl, Br, I, which is the iodide, and fluor. Usually, the most famous halogen that is used in alkyl halides are Cl, Br, and I, which are the chloride, bromide, iodide. Okay, fluoride is also used, of course, in alkyl halides, but it's not very frequently used in the reaction because we consider the fluoride not as a good leaving group during reaction as the rest of the halides. Okay, so alkyl halides are compounds that are composed of alkyl groups and a halogen, or we can consider it as an alkane by removing the hydrogen and replacing this hydrogen or any of the hydrogen with a halogen. Of course, there are also alkyl halides that contains more than 1 halogen, dihalides or so, but now we are concentrating on the alkyl halides with only 1 halogen. Okay, examples: iodoethane or ethyl iodide, in which in the ethane Okay, CH3, CH3, one hydrogen is replaced with iodide. Another example is 2-chloropropane. 2-chloropropane is derived from propane by replacing one hydrogen with a Cl. 1-bromo-2-methyl or 2-methyl propane is an alkyl halide in which one hydrogen is replaced with a bromo group, with a bromide. With a bromide. Now we came to the common names of alkanes. For the common names of alkanes, we have many examples. Common names are usually, of course, they are still used today somehow, and there are some prefixes that are used at the beginning of the name of the hydrocarbon to indicate that this hydrocarbon is an isomer for the alkane or for the hydrocarbon. Common names of alkenes are still used today, and they are just prefixes that are added to the name. For example, iso, secondary, tertiary, and neo. Let's see examples of the common names so we can understand what we are speaking about. For example, let's start with pentane. Pentane is an alkane, okay? Pentane, let's start with pentane. Pentane is an alkane which contains 5 carbons. If the compound is in the form of a straight chain, no branches at all, so we add the prefix N to the name. This means this is normal pentane. N here means normal. Normal means straight chain. N here means normal, and normal here means straight chain. So this means that I have a pentane in which the carbons are forming straight chains, no branches at all. Okay, similarly, for example, if I have heptane, heptane means 7 carbons. If the 7 carbons are in a chain or straight chain, no branches at all, I add the prefix in. So this means I add the prefix in, and this means that this is a straight chain of heptane. Okay? Okay, so what if I have a methyl group or a branch at carbon number 2 of any alkane? Okay, if I have a branch or methyl group like this at carbon number 2 of an alkane, for example, this is carbon number 1. This is carbon number 2, and here is the rest of the chain. So if I have a methyl group at carbon number 2 of the hydrocarbon, so this hydrocarbon is not anymore a straight chain only. There is a branch on carbon number 2. In this case, I add the prefix iso just in front of the alkane name. For example, if I have butane, butane means this is 1, 2, 3. 1, 2, 3. This is butane. This is butane. Okay? If I have a methyl group at carbon number 2, then I'm going to add the prefix iso before the name. So, always remember, when you have a methyl group at carbon number 2 of the alkane, add the prefix iso to the name. Okay? Also, in the common names, remember to count all the carbons in the compound, not only the carbons that are in the chain. For example, here I have, as a total, I have 4 carbons. So this is a butane. As a total, I have 4 carbons. So this is a butane. But what type of butane? It's not normal butane, because all the carbons are not at a straight chain or are not forming a straight chain. There is one carbon which is branched at carbon number 2 here. There is a methyl group. So this is iso. Okay, so iso is a common name when we have a branch of methyl group at carbon number 2. And remember, in common names, to count all the carbons in the compound. So this is isobutane. What else are examples? Let's see pentane. Pentane. If I have only pentane, so this should be just a 1, 2, 3, 4, 5. This is N-pentane. This is pentane in which all the carbons are in a straight chain, that type. But if I have an alkyl group, here at carbon number 2 and specifically a methyl group, if I have a methyl group here at carbon number 2, so now I have iso. So in this case I have isopentane, because iso is a prefix that's added because I have a methyl group at carbon number 2, as you can see, and pentane because the total number of carbons at the compounds are 5 carbons. Let's go to isohexane. Iso is a prefix that is added. Iso is a prefix that is added just because we have a methyl group at carbon number 2. 1, 2, 3, 4, 5. And of course, this is also counted as number 6. So the compound is hexane. The compound or the alkane is a hexane, but it's not N-hexane. If I have all the carbons at the same chain, okay, if I have the carbons are all at the same chain, connected as a chain, so this would be hexane. But if I have one of the carbons are converted or are a branch at carbon number 2, so this is going to be a methyl group at carbon number 2. This is going to be a methyl group at carbon number 2. So I have to use iso prefix. Okay, let's go to another type of common names. We have here neo. What is neo representing? Neo is representing when I have 2 methyl groups at carbon number 2. So in this case I call this, or I use the prefix neo. Okay, let's have examples. In this compound we have 1, 2, 3, 4, 5. So there are 5 carbons. 5 carbons means pentane. Are those 5 carbons in a straight chain? No, they are in a branch. You can see a branch here at carbon number 2 and branch here also at carbon number 2. So if you have this shape, which is between the red brackets here, okay, if you have 2 methyl groups at carbon number 2, this is carbon number 1, this is carbon number 2. If you have 2 methyl groups at carbon number 2 as branches, so you should add neo. And here you should add neo, and here please add the name that is corresponding to the total number of carbons. Okay, let's test our understanding here. Sorry, here should be a methyl group. So here we have 6 carbons. 1, 2, 3, 4, 5, 6. So the corresponding alkane is hexane. But this is not a straight chain hexane. So it's not N-hexane. Here there are 2 methyl groups that are bonded to carbon number 2. Or they are a branch here. You have one branch in a form of methyl group that is connected to carbon number 2. In this case, you should add the prefix neo. Okay, so now in general, we have now examples in the common names, as you should add a prefix N in straight chains, iso in if you have a methyl group at carbon number 2, and neo, here is iso, and neo if you have two methyl groups at carbon number 2. And remember to count the whole carbons at the compound. Of course, here all the examples we gave was using methyl groups, simple methyl groups, but the branches can be larger. We can be larger branches. We can be more. We can have more alkyl groups, different types of alkyl groups, as you can see. So in this case, how can we give a common name for the compounds? It starts to be very complicated. So for that reason, there is in the common name, there is a lack of specificity and simplicity. Common names don't provide specific information about the structure and the property of the hydrocarbon. Also, common names are getting more complex as the organic compounds gets bigger, okay, or larger in size. For that reason, the International Union of Pure and Applied Chemistry put some rules or a systematic naming system that we can use, which is called IUPAC naming system. We can use to describe or use or putting or giving name for the organic compounds. Now, to understand those rules and to be able to apply them, we are going to apply them first on the simple alkanes. So let's discuss about the IUPAC naming system. Let's see what are the IUPAC naming rules. Let's see now what are those rules. First, if you are going to give a name for an alkane or a hydrocarbon in general, please select the longest chain and name it as the basic alkane by adding the suffix -ane. So first step is that we have to find the longest carbon chain. Okay, and according to the number of the carbons, we will give this compound or this longest chain the name of the corresponding alkane. Number 2, you have to give numbers for the carbons in this longest chain if you have branches or alkyl groups. Number 3, if you have more than one alkyl group or more than one branch of the same type, please use di, tri, tetra to describe the number of the alkyl groups. Number 3, use commas between numbers and hyphens between a number and a name or a letter. Number 4, if you have more than one type of branches, please order the branches in the name alphabetically. So now we have many of those rules, and to understand them well, let's see examples, because you will understand all the rules through the examples and the exercises. Let's have the first group of examples or exercises. As you can see, for the first compound, for that one, this is a compound which is, if I'm going to name it according to the common name, I'm going to give it iso, because we have here a methyl group at carbon number 2, and the overall compound contains 4 carbon, meth, eth, prop, bute. So this is meth is propute, so this is isobutane. But if I'm going to use the IUPAC system, the story will be much easier. I'm going to select the longest carbon chain, which is that one in the red font. So 1, this is this is carbon number 1, carbon number 2, carbon number 3. Okay, and at carbon number 2 I have a methyl group. So simply the name of this compound is going to be, I have 3 carbons here, so meth, eth, prop, this is propane, and at carbon number 2 I have a methyl group, so this is 2-methyl propane. Okay, Let's go to the second one. In this compound, to give it an IUPAC name, I would have to choose the longest carbon chain, which is that one in the red color. Okay, I have carbon number 1, 2, 3, 4. So this is meth, eth, prop, put. This is butane. And at carbon number 2, I have two methyl groups, as you can see at carbon number 2. So according to the IUPAC rule, that if you have more than one of the same type, please use di, tri, tetra, and so on. So I'm going here to use dimethyl. So in here I have 2 dimethyl propane. Sorry, butane. 2, I have here 2 dimethyl butane. Why 2? This means that, as you can see, at carbon number 2, I have 1 methyl, and at carbon number 2 also, or again, I have another methyl. So I used to say 2 dimethyl. 2 methyl groups means 2 methyl groups, butane. Okay, so this compound is 2 dimethyl butane. And always remember that between the numbers to use a comma, and between a number and a letter use hyphen. Okay, let's see the third example. In the third example, I will apply the IUPAC rules again. So first rule, choose the longest carbon chain. What is the longest carbon chain? Here is the one, which is in red color here. Meth, eth, prop, put, pent. So this is pentane. Pentane, the mother compound or the mother chain is pentane. And at carbon number 2 we have a methyl, and at carbon number 2 also we have another methyl, and at carbon number 4 we have a third methyl. So now we are going to say that this is pentane, and pentane, and at carbon number 2, and at carbon number 2 again, and at carbon number 4 also, we have trimethyl pentane, as you see. Okay, and don't forget to use hyphens between numbers and, don't forget to use commas between numbers and hyphen between a number and a letter. Oh, let's go to this exercise. Name the molecule below. Here we have that molecule that we would like to give it an IUPAC name. Okay, remember the rules of the IUPAC is first to select the longest carbon chain. Okay, first select the longest carbon chain, longest C chain. Then give numbers to the carbons. Give numbers to the carbons. Those numbers to the carbons, you should number the carbons so that the substitution or the branches or the alkyl groups that are attached to the chains are given numbers. Okay, these numbers just to indicate the position at which the alkyl group or the substitution is connected. From the IUPAC rule, if you go back and from the IUPAC rules also, you can see that one of the important rules is that when you give numbers for the carbon atoms, okay, by simple revision to the IUPAC rules, you can see that one important sentence is that when you start numbering the alkyl groups or the carbon chain, number them in a way that the substitution takes the least possible number. Number them so the substitution takes the least possible number. Let's see what is that mean here. Let's see what this means here, or how can we apply that here. So back to the rules. We have first to select the longest carbon chain, which is that one. This longest carbon chain contains meth, eth, prop, but, pent, hex, hept. So basically I have here heptane. I have heptane, 7 carbon atoms means heptane. Then we have 2 methyl groups. They are attached to somewhere on the carbon here, on the carbon chain. So now I have to start to give those methyl groups numbers. If I'm going to start numbering process from here, so this carbon will be 1, 2, 3, 4, 5, 6, 7. So basically I'm going to have 4, this methyl group is at carbon number 4 and the other methyl group is at carbon number 6. So I'm going to have 4,6-dimethylheptane. 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 If I'm going to put or to number the carbon chain from the other side, from the right hand side, the numbers will be like that. 1, 2, 3, 4, 5, 6, 7, because I have to give them the least possible number. I have to start the numbering so that the substitution or the methyl group will have the least possible number. So if I'm going to start from the right hand side, the methyl group will take number 2 and 4. So basically I'm going to have 2, 4 dimethylheptane. As you can see, when we started the numbering from this side, from the left hand side, the methyl groups take numbers 4 and 6. But if I'm going to start numbering from the right hand side, the methyl groups took number 2 and 4. So this is less than that one. This is less than that one. This means that here this is correct, or this is more matched the IUPAC rules, because here the substitution have the least possible number. So in this case I have to start numbering from the right hand side so that the substitution in that case will have the least possible number. So now let's summarize what IUPAC rules we learned until now so far. Okay, we have first we have to choose the longest carbon chain, or select the longest carbon chain. Give the longest carbon chain the corresponding alkane names, and then whenever you have a substitution, one substitution or more, please start numbering from the side of the chain so that the substitution or the branches or the alkyl groups will take the least possible number, because this is the most correct IUPAC name. Okay, so in this case this compound is 2,4-dimethylheptane. We choose to number from the right hand side because numbering from this side will give the 2 alkyl groups the least possible numbers. Let's have more exercises for this compound. Okay, please give it an IUPAC name. Okay, according to the IUPAC rules, I have to select the longest carbon chain. So now the chain is going everywhere in all directions, but I have to select the longest carbon chain. What about that one? Like that. Is this a longest carbon chain? Yes, I think. Okay, and of course I can take that downward directions. It means I can, instead of using this methyl group, I can go down there. It means I can go like that. Like that. This can also be the longest carbon chain, okay? And they are of equal length. Either to go like this, okay, or to go upward. They are, both of them are longest carbon chains, and they have same length. Then what I have, what alkyl groups I have here, or what substitutions I have here. I have that one, which is methyl group. This is methyl group, another methyl group, ethyl group, and another ethyl group. So I have two ethyl groups and two methyl groups. The longest carbon chain is here: meth, eth, prop, bute, pent, hex, het. So basically I have heptane. Basically I have heptane, 7 carbons, okay, and 2 methyl substitutions and 2 ethyl here. Now I have to write those substitutions or alkyl groups so that they will take the least possible number. So now I have to check which side I should start the numbering so the substitution would have the least possible numbers. If I'm going to start from here, so I will have 1, carbon number 1, 2, 3, 4, 5, 6, 7. So in this case, I'm going to have 2, 3 dimethyl, 2, 3 dimethyl, heptane, okay, and also I'm going to have 4, 4 diethyl. So we have 4, 4 diethyl, 2, 3 dimethyl heptane. Make it here, okay? Why I used diethyl here, or I placed the diethyl before the dimethyl? Because one of the IUPAC rules is to order the alkyl groups or the substitution alphabetically. So the E in ethyl alphabetically before the M of methyl. So we should use or put the ethyl first before the methyl. Okay, so according to the numbering, if I'm going to start from the right hand side here, I will have 4, 4 diethyl, 2, 3 dimethyl heptane. What if I'm going to start, or what if I started the numbering from other side here? So I will have 1, 2, 3, 4, 5, 6, 7. So I'm going to have 4, 4, still 4, 4 diethyl if I'm going to start from the left hand side. Here this is right hand side. So I will have 4, 4 diethyl and then 5, 6 dimethyl, 5, 6 dimethyl heptane. So which name is the most correct or matches the IUPAC rules? The first one. Why? Because here the substitution took the least possible number. For the diethyl, no difference, but for the dimethyl, if I'm going to start numbering from the right hand side, they will be on carbon 2 and 3, but if I'm going to start numbering from the left hand side, they will have, or they will take number 5 and 6. So this is the least possible number. This is, of course, this is larger. Okay, so here this is the least possible number, so this name is the most correct. Remember, according to the IUPAC rule, to put commas between numbers and hyphens between numbers and letters. So now let's summarize again, or let's revise the IUPAC rules which we are applying right now. Until now, we are going first to select the longest carbon chain. And each time I'm going to name a compound, so I'm going to select the longest carbon chain. I'm going to number the carbons, but I should first check whether I'm going to put the number starting from left hand side or right hand side. I choose the side at which the substitutions or the branches are going to have the least possible number, and then arrange the substitution alphabetically. Don't forget to put commas between numbers and hyphens between a number and letters. This is the correct name for that compound. Let's have one more example. You can see we have one more alkane here. All the bonds are single bonds, and the chain is going everywhere. So I have now to select the longest carbon chain. If I'm going to give an IUPAC name for the compound, I can, or I have to select the longest carbon chain. And as you can see, of course, here common names are going to be very difficult. Okay, so IUPAC is a solution to have simple names for all the organic compounds. In addition, the language of IUPAC or the rules IUPAC are understandable by all the chemists around the world, so we can understand each other easily whenever we use compound names. Okay. Okay, now let's go back. Go back again to the compound. Let's choose now the longest carbon chain. To my eyes, I see this is the longest carbon chain. Like that. So don't be tricked if the carbon chain is not straight one, okay, or linear. Okay, so to my eyes, this is the longest carbon chain, and we have here three substitution or three alkyl groups. We have ethyl group here. This is ethyl or ethyl group, and we have here another ethyl group and a methyl group. Yes. Okay. Now we have the longest carbon chain, which is meth, eth, prop, bute, pent, hex, hept, oct, non, d. So basically this is decane. This is decane. Okay? 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is corresponding to decane. Okay? Now we come to the next step. Next step in the IUPAC naming system is to put numbers for the substitution, but those numbers should be the least possible numbers. So now I have to check whether I'm going to put the numbers or start numbering of the carbons from the left hand side or the right hand side, which will give the least possible number for the substitution. Let's count from the right hand side and see. If I'm going to start from here, 1, 2, 3, 4, 5, 6, 7. So the substitution will be at carbons 4, 5, 7. 4, 5, 7. But if I'm going to start from left hand side, let's see what numbers the substitution will have. 1, 2, 3, 4. So this one will be 4 if I'm going to start from the left hand side, and 5 and 6. This one is going to be 6, and this one is going to be 7. So I'm going to have 4, 6, 7. 4, 6, 7. So 4 is same, 7 is same, but here we have 5 and 6. So this is the least possible. This is least possible numbers. So I'm going to start from the right hand side. Okay. So now I'm going to start from here. I'm going to start from here. 1, 2, 3, 4. So I have 4 ethyl. Okay. 4 ethyl and 5 ethyl. Okay. 4 ethyl and 5 ethyl and 6, 7 ethyl. So I have 4. Sorry, 7 is methyl. I'm sorry. So I'm going to have 4 ethyl and also at 5 methyl. So 4, 5 dimethyl. And at carbon number 7 methyl and 7 methyl decane. So now we have 4, 5 diethyl, 7 methyl decane. Okay. The numbering, I started the numbering from the right hand side so that the substitution will have the least possible number. And always remember to arrange or to put the order of the substitution alphabetically. So basically ethyl is before methyl, and don't forget to put commas between numbers and hyphens between numbers and letters. Hyphens between numbers and letters. So this is going to be the correct name. Now let's go to the next example or next exercise. Okay, now we have a compound which we have to give it an IUPAC name. Now, first step, as we know, we have to select the longest carbon number, the longest carbon chain. So the longest carbon chain to my eyes is that one. This is the longest carbon chain. Okay, then I have to check the numbering from right hand side or left hand side, so that I'm going to give the substitution the least possible number, because here we have two ethyl group as substitutions or substituents. Okay, so if I'm going to start from the right hand side, okay, I will have 1, 2, 3, 4. So the two ethyl group will be at carbon number 4. Okay, let's write here. Okay, 4, 4. I will have 4, 4 diethyl. But if I'm going to start from the left-hand side here, I will have 1, 2, 3, 4. Still 4, 4 diethyl. Okay, and the longest carbon chain here, or the mother compound, is meth-eth-prop-but-pent-hex-hept. So it's heptane. Okay, so if I'm starting to count from the right hand side, I will have 4, 4 diethyl heptane, and if I'm going to start from counting from the left hand side, I will still have 4, 4 diethyl heptane. So in this compound, you can start numbering from either sides or from any side. Both will give the same, because the substitutions are located at the carbon which is exactly in the middle of the longest carbon chain. Okay, so the correct name will be 4,4-diethyl heptane, and remember to put commas between numbers, hyphens between a number and letter. Now let's go to the next example. Here I have to choose still the longest carbon chain. To my eyes, there we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have also 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this is the longest carbon chain. I was checking which is the longest. So to my eyes, and after counting, this is the longest carbon chain. This is the longest carbon chain, contains 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically this compound is nonane, 9 carbons. The alkane here, the basic or the mother compound, is alkane. This alkane have substitutions or branches which are ethyl, methyl, propyl even, and methyl. So we have 2 methyl, 1 ethyl, and 1 propyl. The idea now, or the next step, is I have to check which side I should start the numbering from, so that the substitution will have the least possible number. Let's start from the right hand side here, our right hand side. 1, 2, 3, 4. So I have 4, 4, because I have 4 ethyl and 4 methyl, and also at carbon number 5 will be a substitution at carbon number 6. So this is if I'm going to start from the right hand side. Let's check from the left hand side which numbers we will have. 1, 2, 3, 4. So I will have 4 and 5, and I have 2 substitution and at 6, so I will have 6, 6. Okay, from the numbers I can now see that starting from the right hand side will have the least possible number, because here 4 is 4 and 6 is 6, but here 4 and 5 in the middle are less than 5 and 6 in the middle. So let's start from the right hand side. So here I will give 1, 2, 3, 4, 5, 6, 7, etc. etc. Okay, etc. So now I'm going to put the name as nonane. I'm going to have nonane, and I have 4 methyl and 4-ethyl and propyl and methyl. So don't forget to put them or to put them in alphabetical order. Okay, alphabetical order will start from ethyl. So I have 4-ethyl, okay, 4,6-dimethyl, and then 5-propyl. Now I'm ordering the substitutions alphabetically. As you can see, 4-ethyl, 4,6-dimethyl, and 5-propyl. Here E and M, methyl and propyl. So this will be first in the alphabetical order, and then M, and then the propyl. Okay, don't forget to put commas between numbers, hyphens between number and letter. Now we have, I think we have trained enough for the IUPAC naming systems for alkanes at least. There are only few notes that we have to take care about. Let's check this compound. Check this compound, which is written. Let's check this compound. Here it's written, or it's drawn in a structural formula, and here in a linear formula. They are equivalent to each other, and if you don't know how to convert this formula to the linear formula, please check the YouTube video about the linear formulas, or the short or the different formulas of drawing hydrocarbons in the same channel, in this channel. Okay, okay, let's go to the compound. If we have this compound and I would like to give it a name, so first step is to choose the longest carbon chain. As you can see here in this compound, there are 3 possible numbering, and all the chains have the same length. For example, I can start from here, 1, 2, 3, 4, 5, 6. As you can see, this, in which here we have in blue 1, 2, 3, 4, 5, 6. This is a longest carbon chain, and there are 6 carbons. I can have a different route, and they will also have 6 carbons. As you can see, I can start from here, 1, 2, 3, 4, 5, 6, like this compound. And I can also have a third route in which I can start from here, 1, 2, 3, 4, 5, 6. As you can see, we have 3 of those longest carbon chain, and they are all equal, contains 6 carbons. Which route I have to choose, which carbon chain I should choose? According to the IUPAC rules, choose the carbon chain at which the substitution will be simplest or smallest. Okay, choose the carbon chain at which, if you have more than choice and they are all of equal number of carbons, choose the chain at which the substitution attached to it are the simplest or the smallest. The simplest or the smallest. Okay, so for example, let's check which of them have the smallest or the simplest substitution. If I will choose that one, okay, here we have methyl, and ethyl and methyl substitutions. If we have the other route, we have still methyl, ethyl, and methyl. But if we choose this in magenta color, this in the pink color, as you can see, the substitution here is tertiary butyl. It's a bulk group, and methyl. So this is not the most correct choice or the most correct way of giving the IUPAC name, because the substitution here is the bulkiest. Here are simple. Okay, in those 2 compounds, the substitutions are the simplest. Okay, So choose usually if you have the same conditions, same chains or same number of carbons at the chains, okay, and it's the same compound. So usually you choose the route or the chain which will bear the least or the smallest or the simplest substitution, and consequently it will be the chain with the largest number, because as they are going to be smaller they will be much more. As you can see here in the tertiary probiotic there are only two groups, two substitutions, but for the rest of the choices or the rest of the examples you can see we have very simple groups or substitution, but they are more. Those are the correct. Choose when you have more than one choice and all the carbon chains are of similar length. Choose the chains which will bear the largest number of substitution or the simplest substitution, not the bulkiest one. So apparently those are the correct choice and they are very similar, okay, to each other. So I'm going to name this compound as you can see, 2,2,5-trimethyl 3-ethyl and hexane. Okay, this is the correct name. Avoid to name this compound as here as 2-methyl-4-tertiary butyl, okay, if I have a simplest substitution or if the simple substitution can be much more simple. Okay, let's have the last examples in this. First we have, let's explain. We have this compound. Of course, those compounds now are drawn in a linear or shorthand formulas. And as I said, that if you don't know how the structural formulas can be converted into linear formula, please check a video of the same title in this YouTube channel. It's about writing the compounds in shorthand formula or linear formulas, okay? So if I have this compound here and I would like to give it a name, so I choose the longest carbon chain, and here I just want to mention to you that we have also this group, okay, which looks like a fish tail, you know, a fish tail, something like this, as if we have a fish tail here, like this. This is called isopropyl. This is isopropyl group. So here we have 4-isopropyl, and this is propyl, normal propyl, because it's a straight chain. This is isopropyl, okay? So we have here isopropyl. So this is 4-isopropyl, 5-propyl octane. And of course the isopropyl and the propyl, they can have the same order, no difference. Okay? Okay, if we have that compound, a compound like that, here the longest chain is 13 carbons, so this is called tridecane. We have here about the substitution, we have ethyl, and we have another substitution here. This substitution can be described, it can't be described by one word. I can't say methyl, propyl, ethyl, or even secondary or tertiary or so. So if I have a substitution like this, I name this side chain according to the IUPAC naming system too. Okay, so I say that at carbon number 7 I have a side chain that it can have a separate name, but this chain name I put it between two brackets, as you can see. Okay, so now I have the longest carbon chain, which is tridecane, and at carbon number 5 I have a normal ethyl group, but here at carbon number 7 I have a compound that I cannot describe it in only one word like ethyl, methyl or so. This compound should be named according to the IUPAC naming system separately and put the name between two brackets under the carbon number 7. Okay, so if I'm going to name it this separately as a side chain, I will give the connection carbon as number 1. Okay, so this is 1, 2, 3, 4. So I have meth, eth, prop, but. So this is butyl. This is butane or butyl because it's an alkyl group. Okay, this is not the mother compound, this is a substitution, so I have to put ul. So I have butyl. And at this butyl, at carbon 1 and carbon 2, I have difluoro 2F. Okay, so this is 1,2-difluorobutyl. 1,2-difluorobutyl. This is all at carbon number 7 of the tridecane. Okay. Okay, let's have here the last example, which I also would like to show you. We have here a compound in which I have to apply the IUPAC rule to give it a name. So according to the IUPAC rules, first rule is to select the longest carbon chain. So I can see that the longest carbon chain is that one. Don't be mistaken and go like this. No, this is just a bond and this is just an alkyl. Okay, this is cyclohexyl. Okay, because you know that cyclohexene usually exist in a boat form or a chair form, and the chair form is the more stable than the boat form, so it takes this shape. So this is cyclohexyl. Okay, let's see whether I'm going to start numbering from carbon number 1 from the right hand side or left hand side. I'm sorry. Okay, so let's check that. If I'm going to start from the right hand side here, let's see what the substitution, what type of number substitution will be. Okay, so we have 1, 2, 3, 4, 5, 6, 7. So basically I will have 2,2-dimethyl and 7 and 5-chloro here and 7 cyclohexyl. So I will have 2, 5 and 7. If I'm going to start from the left hand side, I will have 2 cyclohexyl and 4-chloro. So I will have 2, 4 and 5, 6, 7 dimethyl. So it's very clear that if I'm start the numbering from the right hand side, it will have the least possible number, because here we have 7 and 4 and 2. If you are confused between the number, you can take the summation, sum them up and check. So here you have 7, 14, 7 plus 7, 14, 14 and 4 are 18 and 2 are 20, but here 7 and 5, 13, 2 plus 2, 15, and plus 2, they are 17. Right? Am I right? 13? Yes, so this is the least possible number. So we will start to number from the right hand side, from here. Okay, so we will have 2,2-dimethyl and 5-chloro and 7 cyclohexyl. Okay, and please arrange them or put them in alphabetical order. Okay, don't forget to put commas between numbers, hyphens between numbers and letters. I hope you enjoyed this. Now we came to different type of examples, which are compounds that contains cycloalkanes. How can we give IUPAC name, or how can we apply the IUPAC rules to give names for those compounds? First, as you can see, we have one more example here, and this compound contains a cycloalkane and a side chain. In these cases, when I have a compound that contains cyclo, or a ring, and a side chain, I have to count the number of carbons in each. I have to count the number of carbons in the ring and the number of carbons in that side chain. The one which will have the largest carbon numbers, or the largest number of carbons, is this compound. In this case, it's going to be the mother name. For example, let's see example. In this compound, I have a ring. This ring contains 1, 2, 3, 4, 5, 6, 7. 7 carbons, okay, in the ring. But the side chain, 1, 2, 3, 4, only 4 carbons. In this case, the ring contains larger number of carbons, so the ring will be considered as the mother compound. So 7 carbons is corresponding to heptane. So the mother compound here is cycloheptane. The mother compound here is cycloheptane. Okay, cycloheptane. Let's write it here. Cycloheptane. Okay, and the side chain, this side chain is tertiary butyl. Tertiary butyl. Okay, so we have tertiary butyl. Why we said tertiary butyl? Because this is meth, eth, proput, and this is abutyl. And this, when we have a butyl in which all the carbons are attached to one central carbon, we say this is tertiary butyl. As we can see, we have C and methyl, and here is attached to the rest of the compound, so this is tertiary butyl, and it's drawn in the linear formula like that, okay, and then we have the rest of the compounds. So this is tertiary butyl because all the carbons are attached to the central carbon, which we call it usually tertiary carbon, and we will explaining this into a separate video about the tertiary carbon and secondary carbon and primary carbon and so on. Okay, so now we have this cycloheptane as the mother compound and a tertiary butyl as a straight chain. So this compound is called tertiary butyl cycloheptane. What other example we have? Other example here is that compound. It's drawn in the linear formula, and here, as you can see, structural carbons are written as they are. Okay, both are equivalent, they are same compounds. So now let's see how we can give these names. So as we said that I'm going to check or to count the carbons of the side chain and the carbons of the cyclic compound. The one with the largest number of carbon atoms will be the mother compound. Here we have butane. Okay, butane, cyclobutane. This is cyclobutane. But on the side chain we have 5 carbons, as you can see. So we have here pentane. So this is larger in the number of carbon. Okay, contains much more carbon atoms than in the ring. So this will be considered as the mother compound. This one is the mother compound, and this is the longest carbon chain in it. Okay, so we will have here 1, 2, 3, 4, 5 carbons. So I'm going to have pentane and start to number this pentane, this chain. Okay, if I'm going to start numbering from the right hand side, I will have 2 and 5. But if I'm going to start numbering from the left hand side, I will have 1 and 4. So apparently left hand side is the least number. The substitution will have the least number. So this is the carbon number 1, 2, 3, 4 and 5. So I'm going to have 1 cyclobutyl, okay, and then 4 methyl pentane. Okay, so this is a correct name. 1 cyclobutyl, 4 methyl pentane. Let's go to the next example. Now we have the next example. Similarly, we have a compound that contains a ring and side chains. So I have to check. Of course, here by eyes, I can see that the cyclo compound or the ring contains larger number of carbons. So this is going to be the mother compound. I will consider this as the mother compound. So I will have here cyclohexane. Okay, and I have side chains, but here at 2 positions of the ring. in this compound, in the first compound, I didn't need to put numbers on the ring because I have only one substitution. But here I have two substitutions on the ring, so I should put numbers. So I'm going to put numbers here on the ring as 1, 2, 3, 4, 5, 6, and so on. But the substitution should have the least possible number. So I can start either here as 1, 2, 3, and in this case I will have 1,1-dimethyl 3-ethyl, or I can start from here, okay, to have 1-ethyl 3,3. So of course I will start from this side. It have the least possible number. So I'm going to put here 1, 2, 3 here. So I have 1,1-dimethyl 3-ethyl cyclohexane. Okay, and don't forget the alphabetical order and commas between numbers, hyphens between number and letters. Let's go to the last example. Okay, as you can see here also we can see that the ring have larger number of carbons. So cyclopentane here is the mother compound, so we have cyclopentane. Okay, cyclopentane, and we should now put numbers because we have more than one substitution on the ring, so we can put as 1, 2, 3, 4, or 1, 2, 3, 4. We have to calculate every numbering from here, this side, or from this side until we get the least possible number. We found that the least possible number is 1, 1, 4, 4 tetrachloro. Now we have 4 chloro, so we say tetrachloro. So whenever we have 2, we say di, 3 we say tri, and 4 we have tetra. Okay, so here we have tetrachloro and 2 isopropyl cyclopentane. So remember that we have isopropyl and we have tertiary butyl. Okay, those are very important. We have now methyl, ethyl, propyl, and we have isopropyl and tertiary butyl. Okay, so the correct name for this is 1144 tetrachloro 2 isopropyl cyclopentane. This is the last example or the last exercise I wanted to show you. Now, if you would like to know the nomenclature of any alkane or saturated compound, please put it in the comments and I'm going to explain it. Or if you have a compound and its name and you don't know how the name just came like this, just put it also in the comments and I can explain it to you. Many thanks. Bye-bye.